Welcome to the write-up video for Integrity's January XSS challenge. This was a great challenge that has now been concluded. However, you can still play around with the challenge at challenge-0122.integrity.io. But without further ado, let's jump straight into the write-up video. Exploring the challenge. Right now I am on the main page of this challenge. And the first line on this page explains exactly what we need to do. We need to find a way to execute arbitrary JavaScript on the iframed page. So I can scroll down and here we see the page where we need to perform an XSS. Now, however, it's not really nice to work in this iframe, so I'm just going to click the link above here to go straight to this page so that we have it in a full browser window here. And now we can start going at it. We see that this is a super secure HTML viewer. We have a text box and a button. So let's see what happens if I enter the text hello in this text box and we parse it. Okay, this just displays our input. So our input is being reflected on this page. That's cool, that's interesting. Let's just go back and try that again, but this time let's try to input some HTML because this is an HTML viewer after all. Will it parse our HTML? So I'm just going to input h1 hello and then close the h1 tag. So let's see if this becomes a proper header. If I click the parse button, we see that yes, indeed, that parses the HTML correctly and it shows a header. That obviously begs the question of what would happen if we just insert a script tag. So I'm going to go back and insert a script tag that would execute an alert if this runs. Now if I parse it, what will happen? Well, nothing happens. We don't get an alert, so our HTML viewer did not just execute the XSS and we did not just solve the challenge. That is a bummer. But from this we learned something new. We learned that there is some kind of sanitization going around here that is stopping us from just executing an XSS like that. And it makes the goal of this challenge very clear. We need to find a way to bypass this sanitization and to actually execute XSS. But for that, we need to dig deeper. Looking at source maps. So we need to dig deeper into what this application is actually doing. And for that, why don't we take a look at exactly what the server sends to us, the client. So for that, I'm going to inspect element here and I'm going to look in the network tab. We're then going to perform a Ctrl-R to reload the page, and upon doing that we see that 3 files are being submitted to us. First of all, we have this one, which contains the HTML used to render this page. Moving forward, we also have this main.o2ao5519.js file, and if I look into that, we see that that contains 3 lines. The second being the code, and if I try to make Chrome prettify this, we can see that it's not really pretty. I sincerely do not want to look through this mess. However, okay, we can just leave that as this long line because there is another interesting line here, and that's this last comment here. This comment saying source mapping URL equals main.o2ao5519.js.map. Okay, what is that? What is a source mapping URL? It sounds interesting, and it is very interesting, because this relates to a source map. Now this application that we're looking at, it is a React application. We can see that from this favicon that we can view here, which shows the React symbol. But we can also see that from just looking through this code here, because it contains the keywords React quite a lot. But okay, in React we type our code, we create it, we write it, and it's in different kind of files, and we have all our code nicely organized. However, when React is going to compile all of that, it's going to compile, transform, and concatenate it into a single file, for the reasons that it's obviously easier to send a single file from the server to the client than to send a ton of files. It's just easier, nicer, and it will also minify it to send less data over to the client, making everything faster. And that's really, really nice. However, that is a nightmare to debug, as you might imagine, because obviously if there's some client-side issue that you don't really expect, then you would have to look through all of this minified code, and that is a mess. Now, source maps, they exist to go from that minified compiled code that you see here back to your source code. So they create a mapping that allows for going back from this minified code to your exact source code. And that is very interesting. Now, in this case, it looks like a source map might be included here, so perhaps we could be able to go back to the source code. But before we get into that, let's see what the Mozilla documentation has to say about source maps. So going to this documentation, we see here that it talks about using a source map. And in here it says that a source map is a file that maps from the transformed source to the original source, enabling the browser to reconstruct the original source and present the reconstructed original in the debugger. So okay, it seems that the browser might be able to reconstruct this messy file into the source and show it in the debugger. And the next line says exactly what is needed to do that. Well, to enable the debugger to work with a source map, you must, first of all, generate the source map. Now, we in this case, we don't have access over the server, so we can't make the server generate a source map. However, it seems like the source map might already be present here, so that step might already be done. So let's check that out. So in my JavaScript file, I'm just gonna open that in a new tab. So this is what the JavaScript looks like. And then we're just gonna add a .map to the end of this, because that is where the source map was according to that comment. And if I enter that, we see that, hey, this is a source map. This is what it looks like. It's a huge mess, but apparently this is what the browser needs to convert it back into the source code. So okay, we have the source map. That's step one of this done. Now, the second thing that the browser needs to generate that source code is it needs to have a comment included in the transformed file that points to the source map. Do we have that? Well, yes, we do have that, because if we look here, we have this comment that points to the source map. So okay, those two things are set, so the browser, or at least Firefox, but Chrome will probably implement this as well, should be able to go from your minified compiled code here that React creates back to the source code. So let's look in the sources tab of our inspector tools. And here we see that under static, under JavaScript, we see app.js, we see router.js, and then we have these pages here where we have an index.js and another index.js. So yeah, it seems like this is the source code that we have to work with. And next up, we will look through this source code to see what we can find, but this was how we went from our compiled, unreadable, messy code back into our source code using this source map that was generated by the server. Now, do note that having this source map is not a bad security practice per se, because obviously this minification is kind of security through obscurity, and people would be able to reverse it anyway. However, this source map makes our lives so much easier. But stay tuned, because now we are gonna look into this code to see what we can find. Looking at the source. Let's dig into this source code, and let's start by looking at the app.js file, as that is the main file here. We can see that it imports from the router and it returns the router object. So let's just jump into the router.js file then and see what's going on there. So in this one, we see that it starts by initializing this identifiers object with all of these values. And these values seem to be base64 based on the padding on the end. So yeah, we have all of these identifiers as base64, but then the router, it returns something. It returns a root index. So that's the index page, the main page that you go on if you just go to the domain. And that is based on this iox1c. And then we have this route to a path result. So that's /result. And that's based on this i0x1. Okay, what's that? Well, if we look all the way at the top here, we see that we import i01c from this page, and then the other one from these other index.js files that are being imported there. So okay, we can probably copy all of these identifiers because these seem very useful. So let's copy those and let's see in which file we're going to continue. Now the index file, the main page that you see where you can input your stuff, well, that's straightforward. It probably just waits for your input and then sends it through. So I think the result page is the most interesting one to look at here, because that's probably where our result gets reflected onto the page. So let's go to this i0x1 here, which is there. And looking at this file, we see that it imports DOM Purify. So this is probably our sanitization that's happening. DOM Purify is a library that sanitizes a string and make sure that there's no malicious things in there that could cause an XSS. So okay, DOM Purify is being imported here. Then we have some functions here that are very strange, that contain a lot of this window.a2b. What's going on there? Okay, I'm just gonna skip past that for now because I don't understand that. And then we return a div, and the div contains here's the result, and a viewer container which has an element dangerously set inner HTML. And it sets that to a value of a function of a value here, who knows. But dangerously set inner HTML, that's interesting. Well, in React, dangerously set inner HTML is kind of a replacement for inner HTML that you would normally do to interact with the DOM. And React named it dangerously because it is dangerous. You shouldn't use this with user input because that can cause XSS. So React thought, well, we're just going to rename it to dangerously so that developers will see when they're using this, okay, I shouldn't use this because this is dangerous. However, in this case, it was used. So we know that if we control the output here, then that could be dangerous. However, we saw in the beginning that it imported DOM Purify. So obviously, if the sanitization is done in this function, then it might still be secure. But okay. This points to i0x12, and here we see that i0x12 is a function, but it contains all of this window a2b identifiers. What's up with that? Well, window a2b is a function that takes in a string and it converts it from base64 back into ASCII. So it's going to take an identifier here, a specific one, and convert that from base64. So let's see if we can do that in the console ourselves. So I'm just going to paste that in, and oh, identifiers is not defined. So let's just paste all of the identifiers in here. So now this object is defined in my console. Now I can take a look at the base64 again. Okay, that's what it looks like. Now let's see what happens if we base64 decode it. So if I do this, then we see that this one stands for append child. So okay, interesting. We see that this occurs a lot in this file. So do we have to go through all of these and manually go through them? Well, I would rather not do it. So let's quickly write a script that would do this for us. So I'm just going to copy all of this text because we're going to convert this. I'm going to say, okay, my text is equal to all of this. Nice. Now we have our text in a field. And now I want to replace things in that text. So I want, for every identifier that we have, I want to replace in the text where it converts it from base64 to ASCII by its actual ASCII value. So for that, I'm going to start a for loop. And we're going to do a for loop with so create a variable here, call it ID, and I'm going to do that of the identifiers. Okay, so we can create this for loop and run it. However, that gives us an error because identifiers is not iterable because it's an object. And you can't iterate through an object. However, we want to see all the keys of this object. So let's change this to object.keys for these identifiers, like that. Now in here we can quickly just console.log these IDs. And then we see that we get what we want. All of the different identifiers that are available here in a row. Okay, now instead of doing a console log, I want to replace in the text and do things with that. So I'm going to change the text. And I'm going to replace all the occurrences. I'm going to replace all the occurrences of window.a2b identifiers. Open this bracket to quote. okay, and where this specific ID occurs. So every time this string occurs in here with that specific ID, I'm going to replace that with the actual base64 decoded version of it. So I'm just going to do an A to B here, and then just take the identifiers of that ID. Okay, that's good. However, I want to replace that with quotes around it because that will be a string. So do it like that, I guess. And then make sure that this runs like so. I am missing a curly brace here, I guess, and that should be it. So let's now generate this text. There still is a small error in here. I have one extra brace there and one missing bracket there. And now that works and we get some output here. So let's now look through this output and see what we can do with this slightly cleaned up version. So I'm going to open that in Sublime Text here and just paste it in here. And what is this? This doesn't look nice at all. We can see that these \n's have not been converted to new lines. So let's use Control H to find and replace any text \n with an actual new line. Do we replace all? And that already looks way better. And now we can see that this is slightly more readable. Not yet too readable, but slightly more readable. There's some small issues in here, it seems, where this isn't properly done. So let's add some quotes here just to make that work out for us. And now we can start going through this code in a better way. So first of all, we want to look at this IOX2 because that's being used in our dangerously set HTML. Now its first occurrence is here, where we are creating this constant, and it's created by doing a use state, and then we are running this code. So let's see what that will be. So first of all, we're creating this variable based on a new URL search params of window.location.search. Okay, of that we're doing a .get and then getting the payload. So what is this section of code doing? Well, it's going through the URL and it's getting the value of the get parameter payload. So okay, this variable is probably our payload. So let's replace that by payload just so we can work with it easier. Then here we have if there is a payload, then we are creating a new object here and we're setting the __ HTML of that object to our payload, and then we're returning that object. Okay, if there is no payload present, we're doing the same, creating a new object, but this time we're setting its HTML to an H1 saying nothing here, and then returning that as well. So okay, this function or this IOX2 is probably a payload object, an object containing our payload. So let's rename it as such, call that just payload object, and replace all. All right. Now we can keep on working with that here at the bottom. So we're gonna dangerously set inner HTML to this function ran with our payload object. So okay, let's look into this i0x12 function that we can find here. And we know that this first parameter is going to be our payload object, so we can replace that and start working with this. So first thing that's going to happen is we're gonna change the _HTML of this object to dompurify.sanitize. Okay, so we're gonna change the value. I mean, we just created that value, but what are we gonna change it by? Well, this .sanitize is going to be run with our payload object.html. So what this line of code really does, it just purifies our payload. So it sanitizes our payload, so no XSS is possible anymore at that point. Okay, that's a bummer because, well, it would be nice if our payload was just put in this __ HTML without being sanitized, because then we already had an XSS, but that's not the case. However, this function is still long, so we still have more things to find here. Next up is going to create a new variable, and that's going to be a document.createElement with the string template. Okay, so it's going to create a new element with the tag template. Then it's going to set the inner HTML for that new element to be our sanitized payload. All right, and then it's going to do a document.body an append child of that created element. So we're appending that newly created element template that contains our payload object to the DOM, so it's present in the DOM. However, remember it's sanitized, so this is secure. Next up, we're doing something new here. We are getting all the elements, so getting the elements by tag name. By which tag name? Well, by the tag name template. Okay, why are we doing that? Well, we're then selecting the first occurrence of it, which is this one that we just created. And of that, we are going to do something, because we're then going to take the content of that and we're going to run it through this i0xb function. So, okay, we're running a new function with the content of this newly created element template, which is in turn just our sanitized payload. Okay, so with our sanitized payload, we're running this function that we can find up here. So let's quickly change this to payload. Let's call it san so that we know it's sanitized. And let's see what happens here. So here we have a for loop over the children of our sanitized payload. So okay, let's change this to be child. All right, and then for every child we are doing something. We're checking if data-debug is in the attributes of this child. Okay, that's interesting. What is data-debug? Well, that's just a string. So if our payload has a child data-debug, then we are creating a new function here. And this new function is going to take in the attribute data-debug, or the value that that attribute holds. And what is new function here? Well, new function is pretty much just going to create a function that can be executed, and it's pretty much just an eval that doesn't have to be executed yet. However, because at the end here we have these opening and closing parentheses, we are actually executing this function. So this is pretty much just an eval, and we're evaluating and we're running the value of the data-debug attribute in our payload. So here we are actually running something, we're executing something that we control. Because we can create a payload that contains an attribute data-debug, and our payload will first go through the sanitization. However, DOM Purify will not think anything wrong of that, because, well, there's nothing wrong about having an attribute data-debug that contains some XSS. That's totally fine, there's no harm in that, unless the developer is doing weird things, like here, where they are creating a function with that as a string and then executing it as well. So I hope everybody that's watching can now kind of see how this would result in potentially getting an XSS. And, well, let's try to get an XSS right here, right now. So we have our page here, and on our page I'm going to create a payload. And my payload is just going to be a p element, and we know that my p element has to have an attribute data-debug. And we know that the value of this attribute is going to be run. So let's change this value of this attribute to an alert of document.domain. Let's parse that, and we see that we get our pop-up. We get our pop-up with the document.domain. So this was actually executed, and that is how we solved this challenge. Conclusion and outro. In this challenge, we started off by finding a reflection point where our input was reflected on the page. We then figured out that it's not as easy as just getting an XSS there. There is something going on in the background, so we needed to identify what our client was doing with our inputs. But we noticed that it was a React application that had a compiled file that we couldn't easily look into, so we searched for a source map and we found that, and using that we could reconstruct the source code. However, the source code was still pretty obfuscated, which was not really nice. However, we worked around that obfuscation, we de-obfuscated it, and that way we found out how this code was actually working, and we found that it was doing some vulnerable action because it was creating a new function with our payload. Albeit sanitized, it wasn't properly sanitized to use it in that way. And then we exploited that and got our XSS pop-up. That was it for this month's XSS challenge. I hope you enjoyed it. As always, if you have any comments, remarks, comment them down below. And if you want to be the creator of the next XSS challenge, be sure to let us know on Discord or email us at community@integrity.com. I hope you enjoyed this video and I hope to see you back in the next one.